Hi everyone, this is a video for the second half of the trigonometry notes. So we're going to be looking at the sine and the cosine rule, a mixture of examples, so you've got to decide which rule is best to use for the context of the question. Now, a couple of things to keep in mind is that the exam will never say which rule you have to use, okay, so we have to know when to use them. Now, the important thing here on this particular slide in this part of the notes, always assume you have to use the sine rule unless you have the two conditions that are highlighted in the grey boxes. Okay, so always assume the sine rule, A over sine A, B over sine B, and so on, unless we have a case where, so we have two sides and an angle, and we want to find the extra side, so the one down the bottom there. Or if we're trying to find one of the three angles and we have all three sides. So we know for the cosine rule to find an angle, you need to have the sides A, B and C. So if you don't have all those three sides and you're trying to find an angle, then you have to use the sine rule. If you don't have a diagram that looks like the first triangle here at the top, where you've got two sides and an included angle, so you've got the other two sides and the angle inside them, and you want to find the other side, then you can use the cosine rule in that case. Otherwise you'll have to use the sine rule. Okay, so if you don't have those two diagrams, either of those two diagrams, it has to be the cosine rule. Okay, so let's have a look at this first example. Now in this case we have got to find a side, and this diagram looks very similar to the first diagram up in the little explanation section. So for this particular question we are going to be able to use the cosine rule. Okay, so the cosine rule being a squared equals b squared plus c squared minus 2bc cos a. And again, if we remember, our small letters are the sides, so it's the two sides that we don't already have. So x will be our side A, the other two are B and C, and angle A is the one opposite the side that we're trying to find. Okay, so we have the opposite two sides for the ones that we need, and we have the angle which is corresponding to the side that we want to find. So in this case, we use 7 and 9 as B and C, 7 squared plus 9 squared, subtract 2 times 7 times 9 times cos of the angle, which is 95. Okay, so a few things to bear in mind. We've got to make sure our calculator's in degrees. If you're using the online calculator, then you'll be able to see DEG or RAD. So you want to use the DEG for degrees. And then with this calculation in particular, this is one of our easiest ones. We can just shove everything into the calculator. If we're using the cosine rule to find a side, as long as we make sure we get the right symbols everywhere, we should get a number out of 140.981 and so on. Therefore A is the square root of this value that I've just calculated, so on. So I'll keep that in the calculator and square root my answer, and I should get 11.9 to 1 decimal place. So keep that as centimetres since we're working with the side. Now the next question here, we're looking for a side. We don't have two sides with an included angle, therefore it has to be the sine rule. Okay, try and use the cosine rule to find x, and you'll realise that, well, actually I don't have this other side, so I can't possibly use the cosine rule to find x. Okay, the cosine rule, I need two sides when I want to find the other side, but I don't have both those other sides, which means I can't use cosine. So I know it has to be sine. It's finding a side, so I know that the sides are going to go on the top of the fractions. That's c over sine c. Now, what do I have then? So let's say we'll label what I want to find as A, capital A, and B and C can be the other two sides, doesn't matter which way they appear. So I've got side A is what I want to find, I've got side B, I've got angle B, I've got angle C. The only thing I need to find them to use the first two sections of this formula is angle A. Now angle A is in there, corresponding to side A. If I find out 180, take away the two sides within the triangle, that'll give me the angle at A, and I'll be able to use that within the diagram. Okay, and put that into my formula. So that'll give me 53 degrees. So I can rub out the line there, that's 53 degrees up here. Therefore I can substitute in everything now to find out the size of side A. So A is actually side X, which is sine over the angle which corresponds to that, I've just calculated as 53. Side B is 15 over sine of angle B, which is 85. Now remember from doing these a few periods ago, we can multiply the sine 53 up to the top of the fraction on the right hand side. So x is 15 times sine 53 all over sine 85. Now there's a lot of s's for the sines and 5s for the number 5, so just be careful that you can distinguish between those. So it's 15 times sine 53, hit equals, and then divide that by sine 85, and we will get 12.0, so we don't need to have the 0.0 then in, to one decimal place. That will be the size of x. Next question here, we are looking for an angle. Now if we were to use the cosine rule, we do not have all three sides. So to find an angle, we need all three sides if we want to use the cosine rule. Now, in this case, we just don't have all three sides, therefore we can't, and we need to use then the sine rule instead. So since we're finding an angle, I'm going to use the sine rule with the angle terms on top. So sine A, sine B and sine C are the ones on top, and the A, B's and C's, the small letters, are on the bottom. Now if we label what we want to find, so we can use any label for each of these. So I'll go for A for the angle I want to find, which means 13.6 is side A, and I'll say that the other side is C, so that angle 23 can be C and 9.4 can be C. Now B is the other angle and side, which I don't need anyway because I want to find angle A. I've got side A, I've got angle C, and I've got side C. Don't have anything to do with the B's, so they disappear. Now, sine A is sine of x over side A, which is 13.6. That is equal to sine of 23 for angle C over 9.4. Just like we did before, we can multiply up the 13.6 to leave us with sine x equals sine 23 times that by 13.6, and then divide everything by 9.4. Okay, so into the calculator we will go, sine 23, close the bracket if it's got a bracket on it, remember, that way we can make sure that it's sine 23 rather than sine and in brackets 23 times 13.6. So sine 23 times that term by 13.6, hit equals, divide by 9.4, and we end up with 0.5653. Again, I'll keep that number in the calculator just for more accuracy. If you don't keep it in the calculator, just take it to 4 decimal places, that would be enough. So then to find x, this is sine x. To find x, we have to do the inverse of sine, so sine minus 1 on the decimal, and we will get our final answer. So shift sign of the answer, and we get 34.4 degrees, now to 1 decimal place. Now remember, we do need to check that that makes sense within the question. So if we scroll back up, our angle there, where x is situated, is an acute angle, so it would make sense that that would be 34.4. If it was an obtuse angle, remember we would then have to do our cast diagram to find out the larger angle. It's acute, which means 34.4 is reasonable. Okay, the next one here, we have now got 3 sides of this triangle. Now we don't have another angle, therefore we can't find we can't use the sine rule because we need another angle to use the sine rule. Okay, so that's another way that you can remember it as well. But since we have all 3 sides, then we can use the cosine rule. And the cosine rule to find an angle, remember this formula is given to you in your formula sheet, is cos A equals b squared plus c squared minus a squared all over 2bc. Now we're going to have to label what we want to find as a, that way we don't have to change around any of our letters. So 8.5 then is also the a. B and c can be any of the other 2 sides. I don't even need to bother with the angles for this question, so I'm not going to label them in and make the triangle look a little bit more messy. So just leave everything as it is. So capital A can get replaced by angle x. B is 10.2 squared. C is 6.3 squared. Take away a squared, which is 8.5 squared. All of that is over 2 times 10.2 times 6.3. Now remember back to when we did these in the examples, I want you to get a number for each of the top and bottom of the fractions, then we can put that into the calculator. So 10.2 squared plus 6.3 squared minus 8.5 squared. You only ever have 2 or 3 decimal places here, so there's no point in trying to simplify this down or trying to just put all the numbers in. You might as well just write the number down that comes out of the calculator, which in this case is 71.48. And at the bottom, 2 times 10.2 times 6.3 will be 128.52. Now you can either get a decimal number for this calculation, so you can divide the top by the bottom here, or what you can do is you can put it straight into the calculator. So you can do x is equal to cos minus 1 of 71.48 divided by 128.52. So if you're struggling to keep the whole decimal in your calculator, then you can put the calculation in instead. So shift cos, or second function cos, 71.48 divided by 128.52 will give us an angle of 56.2 degrees to 1 decimal place. And again, just always check that makes sense. We are looking at an acute angle, so 56.2 is reasonable for the size of that angle. Okay, so there's the next part of the notes there. So when you go to the booklet for these questions, still Unit 4 booklet as usual, and you will find the questions for these. So there's a mix. You've looked at sine, cosine separately. You will find a mixed exercise on page 33 of the booklet, and that gives you a mix of them all, but also gives you some past paper questions as well, and some rather tricky questions. That goes from page 33 to page 35, and as I say, it'll give you a mix on page 33, and then it starts going on to the trickier questions as well. Okay, so that's where you'll find those, and we'll move on to the next set of notes. Now, bearings is a large part of this topic as well. It's a way that they can add a level of difficulty into the questions that are involving sine and cosine rule. As if the question wasn't hard enough, trying to work out which rule to do, then trying to substitute everything in, they can also add in a level of difficulty with bearings. Now this basically explains everything to do with our bearings. Obviously we just want to think about what's going on here, okay? So bearings are working with north, south, east and west, particularly north. So a bearing is a measurement of the angle from the north line round to a particular point. So for A, the bearing A is going from north round to the line, okay? So it's the angle is the bearing of B from point A. So we're starting at point A down at the bottom of the north line. We're going along the line to point B, and the bearing tells us the angle from the north line to the line that joins A and B. Now in the next note here, the angle at B, okay, so this angle is going from the north line to A in this case. So it's the bearing of A from B. So from B to A. So that might be an easier way to think of it. From B to A. Okay, so start at the north line at B, round till you get to the line that joins up B to A. And then the last one, the green one, we have got from C, so from point C to B, so that's along this line here, going back the way we start at the north line and we go round till we get to that line. Okay, so these, the definitions of these are going to be quite important, as well as how they appear on diagrams. Okay, so the interesting thing as well is that we're going to have to spot different conditions with each of these angles. So we'll see them in diagrams as we move forward. So this is our first diagram with bearings included. So a ship is 1.9 kilometres from the lighthouse. So L is the lighthouse, S is the ship. So the lighthouse is down the bottom of the triangle and S is up top where the ship is. And it's on a bearing of 0.65. So from the lighthouse, we take the north line from the lighthouse, we draw an angle round till we get to where the ship should be, and that's our line towards the ship. Now a jet ski, we've got a jet ski going round the other way, we have got, is on a bearing of 100, so again from the lighthouse we go 100 from the north line to get to the jet ski line, which is down here. Okay, and that's all contained in the diagram for you. What we want to do for part A is calculate the distance between the ship and the jet ski. Now that line is S and J, between the ship and the jet ski. Okay, so what we're now looking for is two sides, maybe two angles, possibly if we have them, to try and find the length of that side. So I'll label this side as X, and what we can see is, well, we have two sides of the triangle. We're trying to find the third side, and we will have the angle contained within those two sides. Now that angle in there is the whole 100, which is the red angle, subtract the 65. So that angle will be in fact 35 degrees. Okay, now the reason for this, the reason this is in this diagram here is so that you can find out that angle, and you can use the angle and the two sides that you're given to find out the missing side. So when we have this diagram, two sides with the enclosed angle, and we want to find another side, we can use the cosine rule. So a squared equals b squared plus c squared minus 2bc cos A. B and C are our two sides, so we'll say that's 0.6 squared plus 1.9 squared minus 2 times 0.6 times 1.9 times cos of the angle, which is at the point across from the x, so that's this angle in here, which we've calculated as 35. So as before with the cosine rule, this is one of the easiest ones to do because everything goes in the calculator, so as long as you put the correct symbols in, you shouldn't have any issues with getting the number to come out. And times that by cos of 35, and we'll end up with 2.1 to 1 decimal place. But if we remember, we then have to square root that to get the value of our a, which will give us the value of the missing side. So keep the answer in the calculator, square root answer equals 1.4 kilometres to 1 decimal place. Okay. Now I need to use this diagram to do part B, so I'm going to get rid of all the points and all the different pieces of information that I've written all over it. You can feel free to go back a few minutes in the diagram in the video if you need to. So now we want to calculate the bearing of the jet ski from the ship. So in this case, now I'm just going to mark in that that angle was 35 degrees because we might need that. In this case, I want to go from the ship, so from the ship, which is here, I'm looking at bearing, so I have to go along the north line, from the north line round to the jet ski. So it's ship to jet ski. Ship to jet ski is round here in that angle. So what I'm going to have to find is the angle contained within the triangle. I'm also going to need this angle in here. Okay, which I don't know what size that is. Once I've got both of those, I can take that away from 360 to find out that angle. Okay. So let's have a look at how we might complete this. So I've got some sides, I've got some angles here. I have also got that this side over here is 1.4. So I've just calculated that. So I can use, for the first instance, to find this angle in here, I can use the sine rule to find the angle. Okay, and I'll show you how I can do that in a second. So if we use sine A over A, and we'll see how all of these parts are going to substitute in. Sine C over C. Okay, so we'll say what I want to find is this angle up here. So we'll say that's A. I've got the side A then, that's 0.6. And I need one other side and angle combination. So there's an angle in here of 35, and there's a side that corresponds to that of 1.4. So we'll call those B's, and we know that I can substitute them in for those numbers. So substituting everything in, I've got sine A, which I don't know what that is yet, over the side, which is 0.6. The other angle that I've got is 35, so sine 35, all over the side, which is 1.4 that I've calculated for that. Now, to find the size of A then, I have to rearrange all of this. I can multiply up the 0.6, make that sine A equals 0.6 times sine 35 divided by 1.4. So pop that into the calculator then. So 0.6 times sine 35 equals divided by 1.4. And we'll get 0.2458 and so on. So A is sine to the minus 1 of each of those decimals, making sure we include it to maybe 4 decimal places just to get enough accuracy. So shift sign of answer into the calculator. That angle in there has to be 14.2 degrees to 1 decimal place. So back up then, and again I'll get rid of a lot of the pieces of information around here that I'm not going to need. So I now know that this angle in here is what I've just calculated to be, which is 14.2. Okay, that's not me finished with this question, however. This one's quite a meaty, complicated question. You're very unlikely to have something like this in an exam, but it's just including every option for you within the diagram. Okay, so the next thing then we need to look at is the fact that this diagram could extend down here, and we would actually create an F angle with the two north lines and the line going through the S and the L. Now on the other side of the angle 65, so that forms a straight line with the angle beside it, meaning that we have 115 at this side here. Now if we've got an F shape, then both angles contained within the F, the 115, that has to be the same as 115 up there. So now that I've got that angle, I will get rid of the two blue lines. I am looking to find this angle round the side, the red angle. I am told that the two sections beside that, or that make up the 360, are 115 and 14.2. Therefore, to finish off B, okay, and again this is quite a complicated question, quite a lot to do, but shows you, the trickiest you'll ever see. So I've got to take both of those angles there away from 360. It's not 180, it should be 360. And that will get me the bearing, okay? So 360, take 115, take 14.2, and we'll end up with 230.8 degrees. Now we want a 3-figure bearing, so round that to 3 figures, so it'll be 204 degrees will be our final bearing. And that's quite a lot to consider within this shape. It's a very, very complicated diagram question, so we'll take it as it is and we'll move on to the next ones. You won't see too many like that, but it has to be shown to you just in case. Now we're on to the past paper questions here. This is a non-calculator past paper question, and the good thing about non-calculator questions are that they give you a lot of help. So this is telling you sine k and sine L are equal to set numbers. Therefore we know we're using the sine rule. Okay, we have to use the sine rule, we can't use cosine rule with having sines included in it. So we're told a bit about this diagram. We're told what this angle is in here, or what this angle makes when it's combined with sine. We're told what this angle makes when it's combined with sine as well. And we're told to calculate the length of LM, which is that side along there. So if I label that side with a K, label the smaller side with an L, and what I'm going to do with this sine rule is, instead of using A, B and C, I'm going to use K, L and M. So K over sine K equals L over sine L equals M over sine M. I'm told what sine K and sine L are. I know what L is, I'm looking to find K, so I'm not going to use M. K, I don't know, but I do know sine K can be replaced by 0.4. Now it's not sine of 0.4. If you have a non-calculator paper, if you find this in paper 1, don't start putting sine of 0.4. You can't possibly work that out without a calculator. So put the number in. It won't ask you to calculate some weird and wonderful creation. Make it 0.4, put that in there. L is 18, and in place of sine L, I put 0.9. So let's have a wee think of what we're going to do with this diagram. So a bit of rearranging, a bit of clever calculation here. Move 0.4 up, we will end up with k equals 18 times 0.4 all over 0.9. Now this is the same as same calculation as saying, well, it could be 18 times 0.4 over 0.9. If I was to time those two together, I would get the fraction that I've got up top. The reason I'm doing this is because now I want to change this fraction, create an equivalent fraction, times both top and bottom by 10, to make this then 18 times 4 over 9. Now I can do that. If I multiply top and bottom by the same number, I can change the fraction without actually changing the calculation it's going to perform. So 4 over 9 is the exact same fraction as 0.4 over 0.9. If you're not convinced by that, pop the two calculations in your calculator, 4 divided by 9, 0.4 divided by 0.9, and you'll find it comes out with the same number. That way we can actually do the calculations a little bit easier. So multiplying these two fractions together, make that 18 over 1, and we'll get, so 18 times 4, you do the calculation at the side, get 72 over 9, and then 72 divided by 9 goes exactly and gives us a result of 8. Okay, so the length of LM is 8, what units are we using? Centimetres. Okay, giving us our final answer there. On to the next calculation. So Katie and Mona are looking up at a hot air balloon, and they're looking up, so K is Katie, M is Mona, and the balloon is represented by B. The angle of elevation from Katie is 52, so we can see down the left hand side it's 52, down the right hand side is 34. Katie and Mona are 350 metres apart along the ground, we can see that marked in the diagram. Calculate the height of the hot air balloon. So this one's quite a common question that you will see in past paper questions. So what we are ideally looking for is this height here. Okay, now one good thing about that height is that it creates a right angle with the bottom of the triangle, K to M. The problem is that it doesn't directly half the bottom, so we can't just use that 350, half it, and then we've got one side of the right angle triangle. What we can do, however, is use all this information to find one of the sides. Either find the right hand side or find the left hand side, it doesn't matter. I am going to find, I'll go for the right hand side here. Okay, so I'll just label all the rest of this triangle, label that as B, label that as M, and I am going to try and find K. So I don't have two sides, I'm trying to find another side, which means I have to use the sine rule. So again, I'll replace the letters with the letters that I've got in the question. So I've got B's, I've got K's, and I've got M's. I want to find K. I've got the angle at K, I've got side B, and I can find the angle at B. So again, remember, if we're working with a triangle, we've got two of the angles, we can find the missing angle that we need to find as well. So angle B is 180, take away 34, take away 52. And we'll get the angle up there at B. Therefore, we can use that in the calculations, which is 94. That's 94 up here, and we now have angle B, so we can use that in the calculations. So if we substitute in everything that we have then, we'll be able to find the size of letter K. B is 350 over sine 94 equals K, which we don't know, over sine 52. I'm going to do 2 steps. I'm going to swap the sides and also times up the sine 52. So K is equal to 350 times sine 52 all over sine 94. So from here, pop that in the calculator, round to 1 decimal place. We'll find the size of K. That's not as done, however, there's quite a lot to do with these particular questions. So 350 times sine 52 equals, and then divide that by sine 94, and we will get 276.5 to 1 decimal place. So 276.5, I can put that number in place of K. That goes into here, so 276.5. Now, with this next part of the question, we're going to have to use something that you might not have explored for a little while yet. So I think we'll probably spend one period during the week before we do these questions on SOHCAHTOA. So, I'm looking for the height, which I'm going to label as X. I now know the one side of a right angled triangle, and I know the angle, so I have everything I need to find the other side. This 350 does not come into consideration in the next part of this question. So I'm going to draw out the right angled triangle. I want to find the side that's the height. I know this is 276.5, and I know the angle is 34 degrees. Now, SOHCAHTOA is a Nat 4 skill, but it does come in sometimes to our questions involving sine and cosine rule. So you've got to label the triangle opposite, adjacent and hypotenuse. Hypotenuse is across from the right angle. The opposite is opposite the angle that you have, so opposite the 34 is up there, and the adjacent is the side left over. SOHCAHTOA. Now we will spend time doing this before, so you should now be up to date with a little reminder of this. So we have the opposite side, we have the hypotenuse side, so we have to use sine, and this sine represents sine x, opposite over hypotenuse. X is the angle, so we substitute in that 34 as the angle. The opposite we don't know, but we can replace by x, and that's 276.5 as the hypotenuse. Eventually, coming all the way down here, we can find out what x is by multiplying up the 276.5, so 276.5 times sine 34. Okay, and that will give us the height of the balloon. Quite a lot of work to get here, but it is worth a nice 5 marks, and you do pick up loads of marks anyway throughout the calculations. So we times that here, we get 154.6 metres as our final answer. Let's just make sure, yep, working with metres. So the height of the balloon, is 154.6 metres. Again, not going to see this in every single question. It does require quite a lot of working, and that's the reason that we did the SOHCAHTOA recap before this question. Last past paper example, I think, yep, it's the last one, is one involving bearings again. So we're looking at this question here, representing positions of 3 places, and we're told about their bearings and stuff, and we're told that they're on this diagram here. So what we are looking for, and the particular knowledge that we want to consider from the pieces of information, is the fact that Dunbridge is west of Earlsfort. So D and E are on right angles to one another with the northern line. We know that because our compass diagrams goes north, east, south, west with right angles in between each of those. So if it's directly west or east, it is on a right angle with it. So that's going to help us out quite a lot when it comes to completing the question. So we want to calculate the distance between Dunbridge and Fairtown. So between D and F is that line there. Now that line between D and F corresponds to the angle E, so I'll label that as E, label the other sides as D and F, and we'll see how we can start to complete the question. Now the first thing we need to do is to find these angles that are surrounding, that are attached to our questions, therefore we can actually complete the question. So I've got 3 angles inside this triangle. None of them are marked on so far, but I can calculate what size they have to be. So the angle in here at D has to be 126 take away 90. The full angle, the full curved line is 126. 90 is the little box up there, which means left over has to be 36. So we've got 36 at angle D. The angle at E has to be 360, take away 230, take away 90. The whole section around here is 230 around the curved line. Right the way around in a circle is 360, and we've also got an extra 90 there where the E is actually sitting. So if we take those away from 360, up here is 40. Lastly, we can find out the angle at F, which we are going to need within the calculations, because we're looking at F and F being corresponding angles and sides. If we do 180, take away the 2 angles within the triangles, the 36 and the 40, we get 104 situated at angle F. So that'll give us everything we need to know, and the reason the bearings were used here were so you could calculate the angles on the inside of the triangle. So I am not given any more than one side, which means I can't use the cosine rule. Now the thing is with these questions, just try a rule, right? Write a rule down, copy it from the formula sheet, write it down, say, right, okay, right, I need to substitute this and this in. Wait, I don't have enough there, it has to be the opposite rule. So if you started here with the cosine rule, you would realise quickly it doesn't work, and you would then just do the sine rule instead. So I'm going to use the sine rule, but just with the different letters that I'm actually given in the question. So D, E and F. And I'm given angle F, side F. I want to find side E, because that's the side DF, which is the one I'm actually trying to find. Dunbridge to Fairtown. And I know angle E as well. No use for the D section of this formula, but I do have uses for the other two. So side E over sine 40 is equal to 15 over sine 104. And we can rearrange this then. Pop the sine 40 up onto the other side. E is equal to 15 times sine 40 all over sine 104. As ever, pop this in the calculator. 15 times sine 40, how equals, divide that by sine 104. And we'll end up with 9.9 to 1 decimal place. Now, our units here are kilometres, so 9.9 kilometres is the different distance between Dunbridge and Fairtown. Again, quite a complicated thing to begin with all the different annotations on the diagram, but hopefully we can kind of understand where that's coming from through the explanation, and just let me know if you've got any questions on that, okay? So you'll find these questions on the past paper questions really here are from page 36 until really the end of the questions. So we've got bearings as well coming into the end also. So the past papers are from page 36 to 41, but after that you've got the bearings rules as well, which we'll touch on when we come to complete those during lessons. Okay. Please, as always, stay in touch with these. Let me know how you're getting on. Send me your work as well when it comes to the end of lessons, and join in just parts of this video as you need to. Okay, thank you.